Hello, I'm Shelly Frischnick. My lesson is from my unit plan. It is structured for a general chemistry class for 10th grade students. In terms of the school year, it'd probably be presented in January, so they'd already have a lot of background on chemistry and know a lot about different elements, and it kind of ties into Taylor's lesson, how she left off with the metals and the non-metals. I'm going to talk about that in a second. This is actually my lesson was planned for a 2-day lesson. This is the second day of the notes, and what I actually did is I had an answer key of the notes, and I gave you guys the first half of the answer key. And so everything else is already filled in if you want to look over that, because I'll be referencing back to it real quick. And you can use it as a reference throughout the presentation. And then it's on the third page, well, the back of the second page actually, where it says balancing chemical equations. That's where today's lesson actually picks up. To start, one more thing before I actually get to the lesson. If you want to look at your other handout, the periodic table of elements. This is kind of where Taylor's lesson left off. There's a line drawn down the middle in bold, and at the top there's a little key. On the left-hand side of the periodic table is metals, and the right hand is non-metals. So if you guys keep that in mind, you can use the periodic table as your little cheat sheet for the activity that's going to be going on during the class today. So the lesson that I presented for the second day, the first activity is going to be a bell ringer as an anticipatory set. It's just going to be one of the homework problems that the students had the night before. They're going to have to write it down, copy it, and turn it in as a complete or a correction exercise. And then in its completion, I'll walk around while they're working and check to make sure everyone did the assigned homework problems. And then that is going to lead us into our lesson where we're going to pick up today. So, if you guys want to look at your notes, look at the balancing chemical equations. There's a definition in that first line there. It says matter is neither created nor destroyed in chemical reactions. So the total mass of the reactants always equals the total mass of products. That's the definition we studied earlier in the semester. Does anyone remember what that is a definition of? Chris?
Is it the conservation of matter?
Yes, very good. The law of conservation of mass or matter, either way you want to phrase it. Put different terms, different textbooks. Okay, so this is a really important topic for our lesson today. If you think about the chemical equations we've been studying for the past week, what you have on one side gives you what you have on the other side. So not necessarily a chemical reaction, we'll think of making a sandwich. If you make a sandwich, you take 2 pieces of bread, say a piece of meat and a piece of cheese. So that would be your reactants, and then your product is going to be your sandwich. So you have 2 different things here. You have your bread, your meat, your cheese, and then on the other side you have your sandwich. But if you look closer at your sandwich, you still have that bread, meat, and cheese. So relating this to our law of conservation of mass, what you have on one side is still the same on the other side, it's just in a little bit of a different form. So you have to make sure that on your reactant side, you have the same as your products. You have the same thing on the product side. And so that's what that next sentence, next fill in the blank there is. And as a little recap of yesterday, can someone tell me what a general chemical equation looks like? Where do we put our reactants? Where do we put our products? So if we have our chemical reaction here, the little arrow in the middle, where do we put the reactants? Sarah?
Reactants are on the left.
Very good, thank you. And so that leaves
Product.
very good, thank you. And like I said in the example just now, for our sandwich, it'd be like our bread, meat, cheese over here, and then your products. It looks a little different as a sandwich, but it's still the same thing. So you can serve your mass from one side to the other. What you need to do is you need to make sure, you need to double check to make sure that you always have that same thing on the reactant side and the product side. So you need to balance your equations. So if we stick with our sandwich we're just having bread and cheese on our sandwich because I'm going to run out of space. And here's your sandwich. How much can you put in this sandwich? What's your sandwich going to be made of? I'm going to make one sandwich. What is your sandwich consisted of to make sure that we still have the same stuff? Mm-hmm.
As a number, like 4 pieces of bread and 2 pieces of cheese.
Yeah.
It will be a total of 6.
Yeah, exactly. So your sandwich, your formula for your sandwich is 4 bread, 2 cheese. Okay, so let's relate this to a chemistry problem. One of the reactions we looked at yesterday was, we'll take the, we'll take a simple instead of it. Okay. It was one of the demonstrations we actually did earlier in class. And I'll erase this up here. Okay, now when you're doing this with a chemical reaction, there's a couple steps that you follow specifically. And there's 2 of them actually. The first one is that you want to make sure, almost all the time, that you have whole number coefficients. And the coefficients are the numbers that you're going to be putting right here. And that's just the number that we're actually going to write in here. And then your second rule is that you balance the elements in a specific order. It makes it a little bit easier to do. And that order is metals first, and then nonmetals, and you follow with your hydrogens, and your oxygens. And yes, oxygen is technically one of those 2 categories, but you save that one for the last. Okay, so if we look at our example here, can anyone pick out the metals in our equation here? Yes, ma'am? Yes, magnesium is a metal, very good. So we'll look at it first. We have 1 magnesium over here, and 1 on this side of our equation. So that's our nonmetals. What are nonmetals here, besides hydrogen and oxygen?
Chlorine?
Yes, very good. Okay, so you have 1 chlorine on this side, and 2 chlorines on this side. So we put a 2 in front of this molecule, so that you have 2 on each side. Next, we want to look at our hydrogens. Reactants, we have 2 hydrogens. Products, 2 hydrogens. So that one's already okay. And finally, you would look at oxygens, which we don't have in this reaction. So your reaction is now completely balanced. These, I mean, you could put a 1 here, but usually it's just understood that that 1 is there. And that's the same with in front of your hydrogen and your magnesium chloride. So does anyone have any questions on this so far? Everyone following along? Yeah. Okay, so on the next page I have a couple examples. You want to look at those while I write them up. You guys want to talk with your neighbors while I'm writing these up and confer, that's fine too. and then I'll see if you guys, do you have any questions out front, first of all? Okay.
In number 3, there's there's 2 oxygens on the right side. So does that just add up to 5? Like
Yes.
Is that
Yeah.
So you're gonna try to add those two together, you want both of those together to balance with just the one L?
Yes, exactly. Does everyone understand what question she asked? If you have an element in more than one molecule, she asked specifically for here, you would just add these, so that'd be 5 oxygens. Okay, well we'll go back to this first one here. Okay, so let's start with our steps. Which one do we look for first? Which kind of element? Sandra?
The metals?
Okay, so can you tell me what metals we have?
We have all non-metals.
Okay, so pick a non-metal to start with.
Oxygen.
Mm-hmm.
Oxygen.
I'm going to save the oxygen to the end. Makes it a
Okay.
little bit easier.
Then, phosphorus.
Okay, so how many phosphorus do we have on reactants?
1 in that side and 1 on the other side.
Okay, so you're already good. Someone else want to pick the next element and keep going with that? Brittany?
Chlorine.
Okay.
It's balanced already.
Okay, then yours is pretty easy too. What are we left with? I'm hearing oxygen coming from the crowd a little bit. Okay, so how would we balance oxygen in this equation? Chris?
We would put 2 in front of the molecule on the product side.
Very good. But that changes stuff a little bit, doesn't it? It doesn't only change the oxygen, we change the phosphorus and the chlorine here. So let's take a step back, and we'll look back at phosphorus. We now have 2 phosphorus, so how do we balance phosphorus on this side? Alex.
2 from the phosphorus chlorine.
Very good. And how about the chlorine? Does it fix the chlorine too? Okay, so go back, double check, make sure you have everything right. 2 oxygen, 2 oxygen, 2 phosphorus, 2 phosphorus, and 6 chlorine. Anyone want to lead me through the next one? Be a brave soul. Okay, Natalie?
Right, so
Where do we start?
first you want to start with your metals. So you're gonna the R metals.
Okay, so now where do we look?
You can start with the phosphorus, and
Okay.
it's already balanced.
Good.
The nitrogen is balanced. The
Okay, good.
oxygen is not. So you're gonna want to add a 3 in front of the N2O. No, just kidding, 6.
There you go.
And then you want to add a 6 in front of the N2 on the right.
So you got everything balanced? Looks good to me. Anyone have any questions on that one? Alright, and our last example, anyone wanna do the same thing? Very good job, Natalie. Thank you. This one's a little tricky. Thank you, Brittany. Go ahead.
First you would do the, I guess, sulfur or arsenic.
Okay, so you can pick whichever one you want.
Well, the sulfur, you'd have to put a 3 in front of the sulfur on the right to balance it. And then you'd have to balance the arsenic, so you would have to put a 2 in front of the arsenic on the left. And then the oxygens, and
Hold
it does,
on. So far you're doing good. But we changed something here.
the sulfur.
Alright, so you gotta take a step back again. Good job, you're doing a really good job. This was a little tricky. Sorry.
That's okay. And so then you'd have to change the one on the right to 6.
Very good.
And then the oxygen, but it doesn't work out at first. So you'd have 15 on the right, but you only have a power of 2 on the left. So you have to change them again.
There's 2 ways you can do this actually, and this is why I have this problem. I kind of tricked you. Sorry about that. You're right. You can change everything, but only with oxygen. A common practice is to put 15 over 2. Since you save oxygen to the end, That happens a lot because oxygen almost always exists in that O2 state. So it's in a lot of reactions like that in O2. So you'll run into that problem where you have 15 and then this is only going to get you a power of 2. So that's just one common, it's a little kink in the system, but it's an acceptable practice. Okay, well very good. Thank you very much for volunteering and helping out. For the rest of the lesson, there would be a worksheet that the students would just keep practicing with this, finding a couple more little snafus like that oxygen. And at the end of the class period, we just go over the worksheet and I'd have a couple students volunteer to write them on the board. And for the rest of the unit, you just continue on chemical reactions and things like that. So thank you very much for being a good class. Any questions, overall comments?
Okay.